ask questions below, and I'll respond quickly or in the next episode of Louis.
Hey, Thomas, good to see you there. We got the contacts back, and Mubot is awake now if you want to check your points. Mubot is wide awake and ready to go. Oh, that light is turned. I'm going to move the light. I turned the light or something. Turning the light. Turn the light around. Turn the light around. There we go. Light is turned around. We're ready to go. Thomas, good to see you. A little chill music here to start. Got everything moved around on my desk. Oh my gosh, how you doing, Thomas? Anyone else here in the chat? Anybody? Bueller. I don't know about you, but I'm feeling 42. Feel my age. Feeling like an old man. Can't see the screen. Oh, get started. See, there you go. You see the wrinkles. There's the wrinkles. Wrinkles. Get old, you get wrinkles. It happens to the best of us. Lucky to get old. That's what it should be. Get old. Lived at 90, 95. Lived at 120. Be good times. Well, we're loading up my Pearson round now as I just ramble. I'm a rambling man. But Thomas, are you still here? Can anyone hear me? Can anybody hear me? Looking... I'm looking at emails right now. Okay. Thank you. Dance. Bring back the due dance. Okay. Noel, good to see you here. So much with the project. So much. It has been a busy day. Have you done chapter 17 completely yet? Made a little bit of cheating on the project.
It doesn't matter.
A little bit of cheating. Not too much yet. We'll find out as we run more checks. I know it happens every semester. Every semester. I tell people don't send anyone the work. Don't let people look at your work. Don't talk to someone while doing the project. Do your own individual work separate from other people. And then people turn in. I wish I could show you it. I can't. But people turn in portions of the project where it's like, you can tell you they change numbers, they change words, and it goes beat for beat, sentence for sentence identical. And then they'll have sentences that are identical, like multiple parts. And it's like they'll have like a high matching percentage, and they'll be like, well, I thought we could work together. Like, no, the project's like a test. As we say, the project's like a test. You're supposed to sit down, do the work, think up your own ideas, come up with your own executive summary, come up with your own ideas. Everyone will say things like the 10% condition, or the random, the 10%, and the success failure. But then it's weird. Some people get the conditions wrong, and then they'll say the same wrong things. You're like, why do you say exactly the same wrong things? Like, exactly, it's when people get things wrong and they're exactly the same on wrong things, that's where it's even more interesting. But we go for the ones that are it's fairly obvious. Yeah, and then not by random chance the two people match, or 3 or 4. We one time had a cheating ring of like 13 people. They were using an old project, and one person even turned it in with the name still on it of the person who had the old project. We make changes to projects and stuff like that, so sometimes you'll see like everything will glow in the project when you run through the checker, except for one section, which is like the section we change. So it's like, okay, so it used this project and you wrote this section different, but you took most of the material from this old project. And they'll be like, I have no idea. And you'll be like, just tell us what happened. That's always what I try to tell students in these scenarios. So if you're hearing this now, you've been contacted by me. I'm not saying anyone here has or hasn't, but if you're hearing this, just tell me what happened. Don't think, how do I get out of this? That's the bad thing to do, because by the time I've contacted you, there's enough evidence for us to believe something happened. Now, I will say this is my last comment for anyone who watches this. I did have one student one time come in, and their roommates stole it from them. I said I needed to talk to them. This is back before we did a lot of things more online. This is like a decade ago now. And I said, hey, can you come to my office and you talk to me about something? They said, sure. They come by and they say, hey, what's up? And they're just like, hey, how's everything going? And I'm just there as chill as can be. And they say, there was this project that was turned in with a high match to you. And you could see like this. They go, my roommate was using my computer after me. And I'm like, okay. And they're like, she must have stole it. And I'm like, And the roommate was like, went to the other professor, was crying and like, I'm so sorry. I took the project. I was using their computer right after them. I said, can I borrow your computer? And I took their project. And like the student knew exactly who it was like right away. Like they were so mad and they were like, oh, they were like, I am talking to her right now. And I was like, oh, you gotta do that. I didn't say it was or anything. I'm gonna, but we have had projects stolen. We had one time 2 guys steal a project. Getting bigger trouble if you steal a project from someone. That was double trouble. So don't say someone stole your project if they didn't, but if someone stole your project, that's really bad. So you're not going to get in trouble if someone stole your project. If someone stole your project, they stole your project. That's theft. So even if you're like, hey, you can use my computer, students should know you don't go onto someone's computer and take their work. Like there's kind of you're not letting them. Now if you say, hey, you can use my computer and look at my project, that's letting them take your project. There's differences here. Like, yeah, I've still got my project open. Feel free to look at it. No, they're not stealing your work if you allow them to. But if they go into your files and start, you get what I'm saying. You know what I'm saying. I've only contacted like 4 or 5 students, but it's 4 or 5 too many. I hate it. I hate it. Hate the whole process of it. Say, Brian, don't find cheaters then. Then you don't have to deal with it. Don't find plagiarism. Don't deal with it. That's just the way. Yeah. It depends. No. The answer is, and so if anyone's watching this, a good question, Noel. Let's show you some points from Ubot. The answer is usually no. They do not usually fail the class just from that. You go to student conduct, and I do want to say this, that student conduct is meant to be a learning experience. And I really mean that. It sounds like some adult thing you say, like, this is meant to be a learning experience. No, we're not trying to fail you out. We want you to be the best version of you when you leave UT. So if you make these errors, we want you to still get a grade that shows your performance, but it's going to be a deduction on your grade. Students get anywhere from 25, 50%, 100% penalty, or removal of a group, or fail the class. I don't think I've ever used the fail the class. That's as extreme as we can go, as we can fail you in the class. I have used a 0 for an assignment group on students. Most commonly, I use a 0 for students on an assignment. Second most commonly, a 50% off. So like the most common thing is a 0 or 50% off, depending on, like if 2 people did the assignment together, I just give 50s. If it's a good assignment, I mean, they might have got like an 80, 90, 95 or something. I'm just like, oh, well, then you split the grade. You both did the work, you get half the grade. You do half the work, you get half the grade. You work together on it as a group assignment, you split the grade. And then you go to student conduct to discuss, as the syllabus says, this is not a group assignment. And you can't sit next to someone and do the same work and come up with the same answers together. So, and I don't fail you. And I don't hold anything against you. I've had people come and apologize to me in person. Which is good. That's fine. I appreciate that. I hold nothing against you. We make mistakes as we go through these things. So it happens. And, people tell stories. You listen to an adult talk about when I was 18, I was 19, you probably get stories now. When I was 10, when I was 12, when I was 15, you just get more stories, and hopefully the stories get less and less as you get older. And then it's a learning experience. They're like, man, I really messed up here. And that's why I send students to student conduct, is because this is maybe something someone's been doing, like cutting corners, who knows since when? Maybe since like elementary school or middle school, they've been, saying to a friend, just send me your work and I'll take a look at it. And no one's said, hey, no, can't do that. And we need rules, and then the rules need to be held to. And that's why I do what I do. It's just my philosophy. So it's a bummer. Well, yeah, which 2 are you stuck on, Noel? Let's do that. Here we go over to my screen. I'm gonna make sure I got everything closed down, because I was looking at this stuff. I'm gonna make sure it's all off my screen. I'm so blind, I have to like put it on both screens. I think it's all off. Sleepy Bunny. Sleepy Bunny's still here. Which 2 are you working on, Noel? We can solve those problems. People be like, oh man, office hours where we do work? We do work in office hours. Okay, I have no screenshots. Got that stuff closed down. I got everything closed down. Looks like it's all closed down. Go sleep, Bunny. Research investigating the size of a bowl. Let's go do this. Wrong screen. Investigate the size of a bowl. Okay, here we go. Get that bad on there. Researchers bowl size. Okay. I think this one gives summary statistics. So this one's going to boil down to, this is it. I believe it's right here. So this is going to be a hypothesis test with summary statistics. The p-value, oh, great job. Then you made it really far in. Okay, I'll go a little bit quickly through the rest of it. So once again, please email if you have questions or Discord, anything you're stuck on. Chapter 17 quiz. Researchers investigated how the size of a bowl. Okay. So with this question right here, what we have to start is the null and alternative hypothesis. The null always has the what sign. No, I'll click it, and then you just got to remember when doing the null alternative hypothesis, the null always has the what sign. And they're asking, did the size of the bowl change the size? You're right. Noel says the equal sign. Notice how it says, does the size of the bowl change the amount people take? You might have a small bowl and you fill it to the brim. And you're like, oh man, I'm just going to small bowl, less calories. And then you get a big bowl and you're like, I don't know, I shouldn't fill this up all the way. So we're just asking if there's a difference in how much people put in. So the null is going to have the equal, that there is no difference between how much people put in a large and a small bowl on average. And the alternative would be there is a difference. So that'll be the first answer. Now this is very important because the sign of the alternative determines how we calculate the p-value. So this choice right here is paramount to our decision to begin with, because if we choose good morning, Clay. If we choose the does not equals, which we chose, we will shade both sides of the curve. If we choose the less than, we shade the left of the curve. If we choose the greater than, we shade the right of the curve. The does not equals shades both sides. So you can see the p-value that we are doing is going to be based on this one right here, which is the does not equals, and we're going to shade both sides of the curve. So very important right there. The sign of the alternative determines what way you shade your test. It says compute the t-statistic. So this is where we have to do the mathematics. So we're just going to go in here, grab the summary statistics. We're going to make it a little bit bigger so we can see it. And then we're going to go ahead and write these equations. The equation is for the t-statistic. It is y bar 1 minus y bar 2 over square root s sub 1 squared over n sub 1. Good to see you there, Noah. We would never put an equals, not equal sign for the alternative. You would never have the equal sign for the alternative. You never have the equal sign for the alternative. The alternative will either be equals or not equals, less than or greater than. The null has the equal sign. So the null hypothesis has the equals. The alternative hypothesis chooses one of those three signs. Good questions, Noel. Which one's the small or the big bowl? I got to look to see which one was the small or the big. It says right, where's the small or the big? It should tell us. It's not, it's going to make a difference on the sign of the T. Does it say, oh, here it is. Large minus small. Okay, this is where, check this out. You see it says large minus small. So large is the first mean and small is the second mean. So that means we have to put y bar large over here. So we could say this is large. Does that make sense, Noel? It's saying large is mean 1 and small is mean 2. So that's an S for smaller over there. It's just the way they've done it. That's how they're doing this problem. That's going to make the t-statistic positive because it's big number minus small number. And so all you're doing is just putting in all your math. You're just taking the equation and solving it out for the t-statistic. And as long as you get these correct on top of the right sample sizes, you are good to go. Please tell me if I make a math error. I commonly just make math errors, especially on these questions. There we go. And so the bottom, square root of that quantity. I always solve for this quantity first. You're going to see me solve the whole thing. It's going to be 2.96 squared divided by 23. And that's that quantity, 1.76 squared divided by 29 plus the other quantity square root. So I should know that. That's about 0.7. So we're going to write that here on the screen, 0.0698. So I think you got to the T, Noel. 0.0698. Good. And you can still see it on screen. Okay. Now we have to do the top of the equation. We're going to copy this, though, and do 6.36 minus 4.86. And it's 1.5 on the dot. Wow, that's pretty. And the T is going to be about 2.1. There it is. So it's 2.15. Okay. Here we go. We'll bring this over here a little bit. So, yeah, Noel, you are doing great. And so what the t tells you, that's 1.5. Thank you, Noel. 2.1477 right there. And it's going to be about 2.15. So what this means is we would go here to a t curve, and we would go up to about here-ish, and we would shade this side, but then we shade the opposite side too over here. This will be a little bit less than what percent, Noel? A little bit less than what percent? And here's a hint for you, because you've probably seen the normal curve where we do this right here, and we're a little bit beyond 2 and -2, like this where -2 would be at, but it's going to be a little bit less than what percent total on the outside. Don't worry if you don't know it. There's a good theory question on the empirical rule and how it works, because in between -2 and +2 is 95%. So outside of it is 5%, but we're further over. Does that make sense? I can show it visually, and then we're going to go find the right answer to this. The p-value is going to be about 3%. Well, 2.5 on either side, so it's less than 5%. It's going to be about 3%. We could guess. Sleepy bunny. I'm going to take guesses, then we're going to look at the right answer. 2.15. P-value about 0.028. No, go here. 3. Where's the alpha? Oh, we reject the null. There is evidence. Okay, did we get it? No. P-value is where we lost. There we go. We got it. So it was a little bit bigger than I thought. So I'm able to kind of visualize where it's at. I was about 3%, about 4%. And that was my guess, and I got it right on my second guess. So how do we know this? Well, I'm going to show it here visually. How do you... Oh, that's what I'll show right here. Good questions, Noel. So whenever you're using the t, every t has with it what's. These are good theory questions. Every t, you need to know its what's. Every t, you need to know its what's to know the shape of it. Every t, you have to know its what's. Every t, you have to know its what, because then you know the shape of it and the way it looks. Every single t has with it this, dictating the shape of it. The bigger it is, the more normal it is. Every t has with it this, the degrees of freedom. So with the degrees of freedom right here, we have to go to the 2-sample t degrees of freedom calculator right here on this applet. We enter in sample size 1, sample size 2, standard deviation 1, standard deviation 2. So those values are as follows. They're up here on the screen, 29, 23. And then the standard deviations are respectively 1.76, 2.96. There it is. It's basically 34 degrees of freedom. You can round it, we'll probably be okay. Now we're going to find the p-value using the t. This is where you find a p-value from a test. You go in here and you enter in your 34 degrees of freedom. And now are we doing above, below, between, or outside? Since we're doing since we're doing the two-tailed test, the does not equals alternative, which of these buttons will we click here? Because we're doing the does not equals alternative. Very important right here. We are doing the does not equals. We will click the what button? The outside, the outside. Between is for conference roles. Good question / answers. Between is for conference roles, like 95% between. Outside is when you shade the outer tails. So we will do you can technically get it from a between because you would take the complement, but we're going to do the outside right here to shade the tails of the distribution and go more extreme than the t we found. We now enter in the t statistic of 2.15 and also its complement or reverse, the inverse of it, negative 2.15. And then we go to 3 decimals, and I got close enough with my guess that it gave me it. I said 0.037, and it's 0.0388, but there's the answer to 3 decimals. Make sure to use the rounding. And so the does not equals test shades the outside. Now, the reason I was able to guess it is because I think, Noel, and you know this, what is between -2 and +2? Basically, what percent? Between -2 and +2 is basically what percent? I mean, it's on the screen now. 68, 95, 99.7. Exactly. So that means outside is 5%. But we are further over than 2, right? We are further over. We're not at 2, we're further over. So that means the area will be what to this? The area on the outside will be what? Because we are further over. Since we're further over, there'll be what area on the outside? Since we're further over than 2, there'll be less. And does that make sense, Noel? Because like I was like, well, it's 5% if it's 2 and -2, but we're further out, which means there's less area in the tails. So I just took an educated guess and said, well, it's a little bit less than 5%, so let's go somewhere around 3%. And I got lucky on my guess. So like if I were to guess this, I'd say I would have said 2 to 3 as my guess. For some reason, I kept thinking there was a little more area in the tails. Maybe I would have said 3 to 4, and I would have been right. It's 3 to 4%. Now, once again, the applets can do this for you. And then the last part of this was to reject the null or fail to reject the null. The p-value down here is less than alpha. When the p-value is low, reject the null. And so does that make sense, Noel? That's how I'm able to do it in my head, is I take guesses via what I know via the empirical rule. So I'm like 95% between, 5% outside. We're further over, a little bit less than 5%. So that's how I make those guesses. Get the p-value. I wish I got it in first try. Man, can't get them all. Which one should we do next? You said there's another one you're working on. Let's do it. That was a really great question, Noel. And Clay, if you have some too, let me know. Yep. If you understand it at that level, I could probably meet statisticians who, there's probably some who don't understand. I just teach the normal curve every semester. I've been teaching the normal curve for 14 years. So you start to, actually, is year 14 now, almost going on year 15. So, I've been teaching almost as long as some people have been alive. I mean, some people have been alive 14 years, but soon I'll be like, I was teaching the normal curve when you were in diapers. Researchers collected many water samples. That's when you sound older. Like, I was doing this a long time. It's all these researcher questions. They're like, hey, did you know what you're doing applies to research? It does. This one's a good one. Have the next one, Ray. I think this one's a quicker question, but this one's also a good theory question. Now, one thing I don't like about this question as I start typing in what it is this one technically would be done with what we call an ANOVA, which is an analysis of variance to compare multiple groups. Because they're not doing a 2-sample T here, come up with something new for 5,000 points. They're not doing a 2-sample T, they're kind of doing a what sample T, which would be better done via ANOVA, because then you get repeated measure. They're not doing a 2-sample T, they're doing a what here? Because this is not, at least in the top graphic, they're not doing a 2-sample T. They're not doing a 2-sample T here. They're doing a what sample T? Do you see it? They're not doing a 2-sample T. They're doing a what? What are they doing? They're not doing a 2-sample T. So this would be a 2-sample. Well, this is what a 2-sample T looks like. In a 2-sample T, you compare the whats of 2 groups. In a 2-sample T, this is the theory that we need to know. The 2-sample T is used to compare the whats. Now, I know I see medians here, but the 2-sample T, yes, Noel, you're getting it. So the 2-sample T is used to compare the difference in the means of 2 groups. Great job. The difference in the means. So you're comparing mean large minus mean medium or whatever, and you're seeing if there is a difference. You're hypothesizing that that difference is equal to 0 according to the null. And you have the mean for the large group, which might be a star right here. It's going to be skewed that way, and this one's going to be skewed this way. So you'd have skew in these distributions, and you'd have to pass the nearly normal. It's kind of a 3-sample T ANOVA, but they go to just do the 2-sample T here by only looking at 2 groups. And that's what a 2-sample T does, is it compares the difference in the means, which would be this difference here between the 2 groups, not the medians. I'm not pointing to the medians. I made a star for where the means are at, which are being lightly skewed towards the low, and lightly skewed towards the high on the box plots. So what would be the null hypothesis be? Well, A, B, C, or D. If you got this on the test, you should jump for joy, because we have a trick to remember. The null has the what? You should look at this and be like, psh, easy question. I got this. Easy peasy. You'd be like, you're done. You're like, I got this. It is D. The null has the equal sign right there. We just wrote out a moment ago. The null hypothesis would state that there is no difference. The difference is equal to 0. And then we have the conditions. Now, they call it independence. I call it random. Random means independence, and depends on how you phrase it. We say if you randomly select your observations, they will be independent of each other. So because of the randomness, it meets independence. That's why you don't want to say they're independent. You want to say we randomly selected them, then you could say that leads to independence. And make sure to remember for the test, the conditions are random, 10%, nearly normal, and independent means. So what do you notice? Nearly normal and independent groups. Now, I'm pretty sure we pass all them. We'll talk briefly about what independent groups means. It means that if you're selecting water from the large pond or the medium pond, it's not going to impact the water from the other pond. And you would believe this is true because they're probably just separate ponds. Now, here's the thing though. If they flow into each other, then they're not independent. Whatever this pond is at would have a mean that is the acidity, which I think remained the pH, would be dictated by the acidity of the other pond. Does that make sense? How the acidity of one pond would be independent of another pond? You're like, are the environmental factors impacting these? But if the ponds flow into each other, they're not independent of each other. If this pond has high acidity, then the other pond would logically have high acidity too, because its acidity is based on what the other pond is because they flow into each other. So that'd be evidence of dependent means, which we would use a paired test. That's another story for another day. The nearly normal condition states that the distribution of the means are nearly normal, and since we have decently large sample sizes, how large are they? It doesn't tell us. Well, that's not fair. Sure. Doesn't really tell us what the sample sizes are. I'll assume they're a large enough sample size that the distribution of these means are nearly normal. There doesn't look to be high skew for the distributions, so the distribution of the means appear to be nearly normal. This last part I hope you get, because it says, what do you do with the null? There's only two choices with the null. What are the two choices? Once again, this appears on the test. Do not use the bad words. What are the only two choices with the null? There's only two choices. So you should write them down and be like, we only do this or this. Reject or fail to reject. When do we reject the null? 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 Reject the null when what? When do we reject the null? You got this. When the blah, 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 reject the null. Mubots, put some notes in the chat. Write that down if you haven't, because you're going to need to write that out on the test. When do we reject the null? We reject the null when the p-value is low. So to figure out what to do for this part, not that, we'll use that in a moment. To figure out what to do right here, to reject or not reject the no. When it's lower than alpha. So reject or don't reject. Here's my p-value. Reject or don't reject. Or if you get it wrong, give it a shot. There's my p-value. P-value less than 0.00001. So do I reject or not reject? Reject or fail to reject? Not reject means fail to reject. Fail to go to the mall, didn't go to the mall. Same wording. Or different wording, same thing. Yeah, Noel said it. Reject, that's low. That's like super duper low. Super duper reject. Now look at what Mubot said. Mubot said, when you reject the null, we then say there is what for the alternative. So when you reject the null, it's because your p-value is less than your alpha. So I would reject my null, that there is no difference between the groups, no difference between the groups of the acidity of the pH, no difference in pH. I reject the null, that there is no difference in the average pH of these ponds, because my p-value of 0.00001 is less than my value of alpha of 0.05 because it didn't state in the problem. This means I do have evidence for my alternative that there is a difference in average pH between the ponds. So I do have evidence. Yes. And does this make sense right here, Noel? You would need to write this out on the test. I reject the null, that there is no difference in the average pH of these ponds because my p-value of 0.001 is less than my value of alpha. This means I do have evidence. And I want you to notice here that the blue choices are what we picked. But if you said, yeah, we're not going to do that. If you said do not, then with do not over here, you would have said I do not because my p-value is greater and I do not have evidence. That's why I like using do not, because the do nots go together. If you do not reject, you do not have evidence. So remember that right there. If you do reject, you do have evidence for the alternative. If you do not reject the null, you do not have evidence for the alternative. And do not reject is the same as fail to reject. Well, I guess that would go over there. But do not reject is the same thing as fail to reject. I just think it's easier when you say do not reject. It's just People will say, I fail to reject the null. So I have to teach you that. I have to teach you what people say so you know how to understand it. So there is evidence because we rejected the null. And there we go. That's a great question. It's just, I figure sometimes people just watch the video and click the buttons, but no, if you know it, you can solve it. If the p-value is low, reject the null. If the p-value is high, just let the null fly. If the p-value is high, I got my context back. Which one should we do next, Noel? Clay, what should we do next? What should we do? What should we do? Oh, I'm gonna fall asleep. I got up early today. Got up at like 6 a.m. 6 a.m. It's a very similar one. We could do this one. This one's interesting. It's a nice and quick one, but put another question in the chat. So that's super duper high. Fail to reject. Yep, there's not evidence. Super duper high p-value, super duper fail to reject. Make sure it's the p-value. Make sure it's not like the t. Make sure it says p-value equals. Make sure it says p-value, not that it says t. Of course, that is the t. It'd be a high p-value too. But yeah, it looks like this one right here, actually. So this one's a really good question. I like this a lot. This question looks excellent. Excellent. Let's do it. Yeah, what's the p-value? And they'll mix it up. That's why sometimes people just click what I click, and then I'm like, no, you have to read it. You have to read the question. They'll change it. Okay, pharmaceutical company is producing and marketing ginkgo biloba supplement to enhance memory. In experiment, they test the product and they do a 2-sample T right here with ginkgo minus placebo. Placebo is a sugar pill, not the real thing. And the T statistic is negative 1.541. Really? I need to tell them that they are making up numbers right here, because that p-value is not the right p-value for that low of a t. They are making up numbers. These numbers are randomly generated because this t would have a p-value of around, wait for it, it's going to be a p-value a little bit more than 10%. They are seeing if it's, no, because it's a greater than test. So it's going to be more than 5%. It's going to be about 6%. And we can confirm this, 6-ish%. Liars, I agree, they've lied here. So what we do is we do the greater than test above and had 198. And it was like, oh, they're doing, oh, no. Okay, wait. I'm not Pearson. I'm sorry. Remember how I said like 6%? No, they're right. Braden, good to see you there. I take everything back. 5,000 points. Please forgive me, my Pearson. Because it's negative and they're doing a greater than test, which usually you don't see. Remember how I said 6%? It's because I was doing it to 2 decimals. And watch this. I said 6%. If you do it to 2 decimals, the answer is 94%. Because I was thinking we were over here on the other side of it. And then I saw it's a negative, and I was like, oh, you're on the left side. So my Pearson did calculate them correctly. That is real numbers. And if you throw the negative on there, you get the 0.938, which is right here. It might even round to that last decimal. You can see right there. There it is, 0.9375. So these are real numbers. Good for them. I just didn't see that they were doing the greater than on a negative, which is not common. That means you found almost evidence against your alternate. Like, you didn't find evidence against null, and you had the wrong sidedness of your test. So what the p-value means in context. The p-value is the probability of our results or results from our stream occurring by random chance given the null is true. And so what this means is what we saw likely given the null is true. And the answer is yes, it's very likely. Something at our result or higher would occur about 93.7% of the time. And the only ones that look like that are this and this. Usually the longer ones, the better. So let's read it. If mean memory scores for people taking ginkgo biloba are the same. So if the null is true, p-value's probability of our results or results from our stream given the null is true. Look at this. There's a probability of seeing the difference we saw. So that's the answer. It's the probability of seeing what we saw. There's the probability of seeing the difference we saw given the null is true. So there's given the null is true. They're saying given the null is true. Here's the probability of what we saw. Very correct. So in conclusion, don't even read their answers. P-value 93. What do? Don't read their answers. P-value 93. What do? This is where you need to think what you do before even reading the answers. What do you do? P-value is 0.9375. What do you do? This is where I've trained you. You go to another class, they say, P-value 0.9375. What do you do? You say, I know what to do. Hide, let it fly. Don't reject. There is no evidence. There you go. That should be it right there. The only one that says there's no evidence, so you don't reject the null, is that. That's all I need to read. The p-value is high, so we do not have evidence for the alternative. There's not evidence for alternative. Evidence is also for the alternative. That's all you need to read. If you know the null is what you believe till you have evidence of the alternative. If you don't reject the null, you do not have evidence for the alternative. That's all you had to read about that question right there. Now, what is the only? I wish I could have everyone bet their whole grade on the class. Like, bet their whole grade. So what's the saying, Clay? You ready? Give me the full saying. What's the full sayings? Write them out. I'll say them here in a moment, but I want you to write them out for you to practice. Give me the full thing, though. Give me the full thing. Noel's on the right track. Noel remembers the mnemonics. You got that. I want the full thing right here. And then write them down. But what's the full thing? What's the full thing? The full entire thing. I'll take just a moment. It's really good practice. Well, you can say do not reject it. So I usually say, right? So you're getting there. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. Just say it repeatedly. Your roommates are going to think you're crazy. Your parents are going to think you're crazy, but you sit around and you go, in a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. This is to, this is fail, this is all that good stuff. So now I want you to say with confidence, which is the only possible error they could make? What is the only possible error they could have made with this? Oh, you're taking type 2. Yes, Braden right there. Let's pin that. So what is the only possible error they could have made? I want to do a question A. Was the only possible error they could have made? Click the button. What is the only possible error they could have made here? What was the only possible error they could have made? No, everyone's afraid. I throw points either way, remember. Sometimes I throw more points for wrong answers, so you might... So here's the thing. Did we reject or fail to reject the null? Did we reject or fail to reject the null? Up here, look at the p-value again. Did we reject or fail to reject the null? Did we reject or fail to reject the null up here? Did we reject or fail to reject the null? We failed to reject. So what is the only possible error we could have made? Say it in the chat. In a type 1 error, the null is true, but we reject it. In a type 2 error, the null is false, but we failed to reject it. Type 2. Since we failed to reject the null, the only possible error we could have made is a type 2 error. Because maybe we should have rejected the null. That is the error. Because if we fail to reject the null, the error is that we should have rejected the null. So in a type 2 error, the null is false and we failed to reject it. So we failed to reject it. So it's not that we made a type 2 error here. It's possible we made a type 2 error. Does that make sense? We don't know we made a type 2 error because if we knew we made it, we wouldn't make it. It's like maybe you go out to eat dinner and you choose the wrong restaurant and there was a really great meal at another restaurant and you never find that out. Maybe you do find out. You're like, this meal is so bad. Surely the other restaurant was better. You hear from a friend and that's where you're like, we made an error. But you might not find out. So in the errors, you don't always find out, but the only way you can make a type 2 error is if you had failed to reject the null. Maybe you were right. Maybe you made the right decision, but you might have made the wrong decision. Okay, any other ones? Tell me more. Tell me more. Tell me more. We can do this one right here. It's another one. New approach. On new approach. The serial one I have videos on. We also did the man going to a new. The Core Plus, a lot of people ask that one. Core Plus is a common one. We've done a lot. A new approach for teaching with the old and traditional teaching method. That was a really great question because it did type 1, type 2 error. That is memorization. Thomas, good to see you there. So some of these really just boil down to memorization. Thomas, how you doing, Thomas? A new approach. Okay. The null has the what sign. The null has the what sign. What are the only two answers we can pick from here? The null has the what sign. The null has the what sign, the equal sign. So with that, it has to be A or it has to be C. This states that the true difference between the new and the teaching, the old teaching method equals 0. There is no difference. The alternative is that there is a difference. This would be that the new teaching method is better than the old teaching method, the traditional teaching method. And the way to think about this, that might be the answer. I'll look in a moment. Preferably when writing these out like this, what I like to do a lot of times is if you actually put the equals there and then you put the greater than there, that means the same thing. So it's a little bit easier to understand, like the new teaching method has a higher average. If you do it this way, you just move the equation around algebraically. And then the null still has the equal sign. It's not written in our very traditional formatting, but this would be the new teaching method and the old teaching method. Traditional have the same mean. This is the new teaching method, has a higher mean. So that is what this one does right here. You can just put the greater than sign between them and it still keeps the equality, because think you would add this to the other side. So it would, if you algebra it to the other side. So what are they asking? They want to ask, are the two groups significantly different? So what answer is it? A, B, C, or D? Are the means between the two groups significantly different? A, B, C, or D? A, B, C, or D? I sneeze. Are they significantly different? A, B, C, or D? It is A, because we're testing for a difference. The alternative does not equals is when the wording of the question implies, is there a difference? Now, the reason this really matters is because when we pick the sign will dictate the way we shade the curve. So because we picked the does not equals alternative, the curve itself will have both sides of the curve shaded. We'll have to do the outside. So we'll have to do the outside of the curve when picking our p-value from the results. The conditions are, condition 1, randomness. Do we randomly select these students to be in each class? 10%. Do we take less than 10% of each student from each class? Nearly normal. Are the distributions of grades from each class nearly normal? Or is the sample size large enough in such a way that the central limit theorem would kick in and the distribution of the means would be nearly normal via large enough n? That is one condition. The nearly normal condition is a big, large condition, which is only a few points on the test, which I've spent days teaching, and I think people still don't understand it. It's all right. It took me a year to understand it. And last but not least, the independent groups, meaning class 1, the new teaching method, and the class traditional are not influencing each other in such a way that maybe the new teaching method students are tutoring the old teaching method students. If they are tutoring those students, then they would be dependent means, because how well the new method learns would then influence the way the older ones learns. Do you think we need to do that, Clay? I hope, maybe, I don't, I'd be open if you think we need to. I might, but I hope not to do such things. The randomness is get your attention, not cause problems. Thank you, Clay. So do you think the conditions are satisfied? I'd say probably yes. I don't see any reasons. Random. Brayden knows random right there. The groups are independent, all this stuff, right? The groups are small enough. We never talk about groups being small enough. We never do that. Refer to the computer output for the hypothesis test. Explain what the p-value means in context. It's like super small p-value. There's the p-value right there. The super small p-value means the differences we saw are extremely unlikely by random chance. The p-value is the probability of our result. T-statistics really off the curve. So as in, like, when you're outside 3 T's or Z's, the p-value is extremely small. So there is a very low probability of seeing the difference we saw, because the p-value is a probability of seeing what we saw given that all is true. So this means for the two classes, there is a less than this chance of seeing the difference as large or larger that we observed. The difference we saw is very unlikely. So since the p-value is low, what do you do? Since the p-value here is low, what do you do? Is this the one you want to know? Well, I think there's ones that have you solve it all out. That's just solving the equation. This is a theory one. Since the p-value is low, very clearly we reject the null and we have evidence of a difference. So, and it says different. So reject the null. And that's what we were looking for. On average, students who learn in the new class method have a different score on average that do not allow them to use their calculators than students who learn by the traditional methods. On average, students who learn in the new class method receive about 29. See, the problem is we're looking for a difference, so I'm a little bit worried on this. Let's find out. I might get the last one wrong. You got confused with D? I think since we're looking for a difference, they really got to go with this one because this is one we find a difference. That's what we find. That's our conclusion. Come on, don't mess with me, my Pearson. There we go. The reason being is because this test was to test if there was a difference, not which one was higher. You could, of course, do a greater than test to see if that new teaching method has a greater result than the previous one, but the question states they are looking for a difference. Always look to the researcher question where it says, are the two groups significantly different? So that's where we chose this alternative. Is there a difference? And our conclusion, we did find evidence of a difference due to the low p-value. Does that make sense? So it all links back to the researcher question is where we determine the sign for the alternative. And there's the sign for the alternative right there. And then we go down here and we state our conclusion. I reject the null that there is no difference between the two groups and their average test scores with a p-value of 0.00001, which is way less than alpha. This means I do have evidence of a difference between the two groups in the means. And something tells me that there might be a positive difference, that the new teaching method is higher. Really good question too, and good theory. I love theory. If you solve out theory, you can get them all. You can get everything correct. Oh, there's no difference. Does this interval conclude an evidence of a difference? Why or why not? Really good question right here. Does this interval right here conclude that there's evidence of a difference? Look at the possible values of the difference. The possible value of the difference is negative 150 to 30. We'll mark this in the notes. Does this conclude there's evidence of a difference? Does this conclude there's evidence of a difference? Why or why not? The answer is no. Because no, and don't worry, 3 points. No difference is what value? If there's no difference, the difference would be what? If there's no difference, the difference would be what? If there's no difference, the difference would be what? If there's no difference, the difference would be what? 0. So you think the difference between men and women is somewhere between negative 150 to 30, and look what's in the middle of that. Like my head. Negative 150 to 30 includes what in the interval, estimating that the difference could be this? It includes 0. So do we think there's a difference? We don't have evidence of a difference because 0 is included in the interval. 0 is a possible value of the difference. So you can see other questions like this right here. This interval is negative. So which mean do we believe is likely larger? Freezer, which is the positive number right here, or counter, which is the negative number. So which of these values is probably a larger one if the interval is completely negative? When the interval is completely negative, it's indication that on average, which one is bigger? Would it be like 100 minus 50? Great job right there, or 50 minus 100. Notice if this is the bigger number, it makes the interval negative. So it's not that it's closer to 0. It's that, and one big, Dorian, good answers right there, good answers. One big miscommunication that people have with this is when you're looking at this right here, it's not that this value is this value. It's not that this value is this value. Those are not the values. That whole interval is this. The whole interval is to estimate the difference between these values. Does that make sense? It's like if I told you, on average, when my brother and I play basketball for a team, I get 4 points and Darren gets 14 points. What would be your best estimate in the difference between Brian and Darren and how many points they get in a game? Don't pretend you don't know stats. Just I get on average 4 points, Darren gets on average 14 points. What is your estimate of the difference between how many points Brian and Darren get in a game? Don't even think stats. Just be like, Brian gets 4 points, Darren gets 14 points. Say, well, I average about 4 points a game, Darren averages 14 points a game. So without any stats, I think people think, oh, these stats is going to be really complicated. No, just pretend we're just talking. Say, man, you get about 4 points a game. Darren gets 14 points a game. No guesses? I get 4 points, 10. but also what 10? Not just 10 though, the way it's written. What 10? So the way it's written, not just 10, because the way it's written, 4 minus 14, you are correct, it is 10. There is a difference of 10 between us. Negative 10. Well, that's not the plus or minus. This is just the difference, which is actually the center of the interval. The difference would be the center of the interval, and then we would do a plus or minus on it with a margin of error. So if you had an interval down here like this, it might be something like -6 through -14. So what is the margin of error that I made up for this example? What is the margin of error that I made up for this example? Yeah, you got to see it a few times, you're like, oh, that's what I'm doing. In this made-up example, the margin of error was found to be what? And maybe I shouldn't, I'm going to change the numbers a little bit. You can say it, but I'm going to change it a little bit more. Because I don't want so many of that number on the screen. There we go, okay. What is the margin of error of the interval? What is the margin of error of the interval? What is the margin of error of the interval? Look at the interval down below. Don't even look at that anymore. Look at the interval only. Because you know how to do margin of errors on intervals, I think. So you need to figure out what this quantity, it's 5, right? Mm-hmm. So what does this mean now? If this is the MOE, and there's that. And remember, these numbers are not, I don't know how to do a not. They're not those numbers. So these numbers up here are not those numbers down there. What does this interval mean? Well, you saw that Darren is getting 10 more points than me in a game, right? You saw he's getting 10 more points than me in a game. But the true difference is that on average, Darren gets between 5 to 15 more points than me. Like, we only have a guess. We've only observed so many games between Brian and Darren, or playing in games, and we saw that Darren gets 10 more points on average than Brian. But the truth is, Darren probably gets 5 to 15 more points than Brian. Does that make sense? And the reason we think Darren gets more is because the interval is negative. We also saw that we estimate that Darren gets 10 more points based on what we saw in games. It's like you watch Brian play a bunch of games and the data would look like this. 1, trying to make everything average out. 7, good, 2, and 6. So it averaged to 4 points a game. And then Darren, who's way better than me, he would get like 16, 12, 10, and 18. So Darren would have an average of 14 points a game. Brian would have an average of 4 points in a game. And then the difference between us is 10 points on average in a game. But then we would estimate, and here I'll show it in jump. We see your brother scores 10 points higher. Yeah, but we think it's somewhere between 5 to 15 points. You could literally, I'm going to do more collecting data next semester. You can go right here and go points and player. So Darren made 18, 10, 12, 16, 20, 8. There we go. And that's Darren. And then Brian did 1, 7, 2, 6, 3, 5. Cool. Symmetric distributions. Bria. Then we go here to analyze, fit y by x. Does the player explain how many points they made? There we go, click OK. You can see the difference. Run the t-test right there, and there it is. And I've been doing too many stats. Why have I been doing too many stats? You guys, I've been doing too much stats. I don't even know. 5,000 points for Brian. I don't even know how I knew that T interval. I've done a lot of stats in my day, apparently. That's very interesting. You see the difference between us is 10 points. That would be the difference between 4 and 14. You can also do this, which is kind of nice. Go to means Nova, and you can see the means right here. The means are 4 and 14. The difference between the means is 10. Does that make sense? If you look at this output, I'll close off the analysis of variance. But if you look at the means, Darren has 14 points, Brian has 4 points. Then we have right here, the difference between us is 10 points because you can see it visually. And it did Darren minus Brian, so it didn't do negative. So notice now the interval is not negative anymore. It's positive because Darren is the leading person. So yeah, I was just kind of thinking what it would be like if it had that sort of interval. And I was like, with a small data set with moderate variation, we should get about this result. I was just kind of thinking through theoretically what would the data look like. And apparently I knew what the data would look like, or close enough that it's basically 5 to 15. The margin of error, does anyone know it to the dot? It's really easy to get the margin of error now. Think about this. The margin of error is half the length of the interval for 5,000 points. What is the margin of error? I can tell you to 4 decimal places the margin of error. Because if you have an interval, you can get the margin of error pretty quickly. That's the pooled. That's a little different. Where's the non-pooled? Here it is. There's the non-pooled. That's why I did even better. I didn't do a pooled T. So if you look at this right here, interval has center, and the interval has the upper number. What is a quick way to get the margin of error right here? What is a very quick way to get the margin of error? I can tell you the margin of error to 4 decimals. What is a very quick way to get the margin of error? I can tell you to 4 decimals. The MOE is half the length of the interval. Well, that's the full length, though, Braden. Good answer. That's the full length of the interval. But the margin of error, so not the full length, the margin of error is just half the length. It's the plus or minus, right? Because plus the margin of error minus the margin of error. So you can have it, but here's the thing also. Why can't you just do the upper minus the what? The upper minus the what? To get the margin of error, why don't you just find the upper's distance from the what? Why don't you just find the upper's distance from the what? The upper value's distance from the what? The upper value's distance from the center, which is the difference, correct? From the center, right? Upper minus center. You're seeing it. So can you subtract 10 out of this and get the answer? Because I'll do it before I can take half the length of the interval. I'm going to take half the length of the interval, which is another way to get margin of error. You go upper minus lower divided by 2. So what is it before I hit enter? Margin of error is going to be what? Last question, then we're going to head off. Margin of error is half the length. The margin of error is half. Boom. Yeah, because you just subtract the 10 out of that. You could do half the length of the interval, or you could just say the margin of error is, you go from the center up, you go from the center down. So you could just say, well, 10 to this is this. You just subtract the 10 off of it. You literally just go in here and you just delete that, and there's the margin of error. Does that make sense, Noel? Like, really good job. You just delete 10 out of it, and there's the margin of error. So yeah, exactly. Watch it. Yeah. Great job. You go center, which is this, minus lower, because that's half the length of the interval. There you go. The more you understand it theoretically, the more you can just solve things, and then it makes sense, and you can double check your work. I don't want to teach you one way to solve things. I want you to understand how to solve it, and then you can just be like, well, the interval has a center, which is the estimate of the difference, at least for the 2-sample t, and then the margin of error is a plus or minus on the interval, and the margin of error is the complicated formula, because a lot of people say, well, isn't the margin of error, it goes y bar 1 minus y bar 2, and plus or minus the t star that you pick based on confidence, and degrees of freedom are complicated formula, square root the standard error formula of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And this whole quantity right here, if you were to solve it, everything right here, this whole thing is the 5.05 or so. If you solve that whole quantity, which you don't really have all this stuff to solve it for. That's got it. With that, we'll be back here shortly. Bye for now, everyone. Bye.